Hey there and welcome. Ever stop to think about what really happens when electricity and liquid get together? I'm not just talking about the whole don't drop a toaster in the tub thing. There's this whole hidden world of chemistry going on, one that we actually use all the time to make our world shinier, stronger, and safer. So today, let's pull back the curtain on this amazing scientific secret.
So here's how we're going to tackle this. Think of it like a little investigation. First, we'll start with a shocking question. Then we're going to, test the waters, literally. After that, we'll look at a tricky little problem with weak currents, find the secret ingredient that's behind all of this, and then the big reveal, what is electrolysis? Finally, we'll see how it all pays off with something called plating with power.
All right, first things first, let's dig into a warning we've all heard a million times. And trust me, the science behind it is way cooler than you think.
You know the one I'm talking about. It's been drilled into us forever. But have you ever actually wondered why? What is it about wet hands and a plug socket that's so bad? Well, that simple question is going to open the door to some really amazing chemistry.
So, to figure this out, let's just do a super quick review. We all know that some solid things, like copper, are great conductors. Electricity just zips right through them. And other things, like rubber or plastic, are poor conductors. They stop electricity in its tracks. That's why they're used for insulation. Simple enough, right? But what about liquids? Where do they fit in?
Okay, time to get our hands dirty, metaphorically speaking. We've got solids figured out, but what happens when we try to send a current through, say, a glass of water?
We can actually build a pretty simple little tester to find out. All you need is a battery, a light bulb, and a couple of wires. You create a circuit, but leave a little gap. Now, if you dip the ends of those wires into a liquid that conducts electricity, it should close that gap, complete the circuit, and presto, the bulb should light up.
So we tried this out with a bunch of different liquids, and check this out. Lemon juice, tap water, milk, they all worked. The bulb lit up. But when we tried distilled water or kerosene or honey, nothing. They're poor conductors. Now hold on a second. Did you catch that? Tap water worked, but distilled water didn't. That's a huge clue. Keep that in your back pocket. But wait a minute. Just when you think you've cracked the case, science loves to throw a curveball. There's a plot twist. So what if the liquid is actually conducting electricity, but the current is just super weak? See, a regular light bulb needs a good amount of juice to heat up its little wire, the filament, and make it glow. If the current is too weak, the filament just stays cold, and we're left thinking nothing is happening. This means our simple bulb tester isn't good enough. We need an upgrade. We need something more sensitive. And there are a couple of cool ways to do this. For one, we could use a magnetic compass. Turns out even the tiniest electric current creates a magnetic field that can make a compass needle twitch. Or an even easier solution, just swap out that old bulb for an LED. LEDs are awesome because they can light up with just a trickle of current. Okay, so now that we have a better tool for the job, let's get back to our big mystery. Remember that clue I told you to hang on to? The whole tap water versus distilled water thing? Let's figure out what's really going on there. And here it is, the big secret. It turns out pure H2O, distilled water, is a terrible conductor of electricity. It's all the other stuff in our tap water, tiny amounts of dissolved minerals and salts, that's doing the work. That's the secret ingredient. And there's a name for these things, salts, acids, bases. When they're dissolved in water, they're called electrolytes. They're what allow the solution to conduct electricity. So it's not really the water, it's what's in the water. And boom, that brings us right back to the beginning. The reason you don't touch a hairdryer with wet hands is because your tap water is basically a saltwater solution, jam-packed with these electrolytes, ready to conduct electricity right through you. Okay, so now we know how liquids can conduct electricity. But the next, even cooler question is, what happens when they do? Because it's not just a current passing through like it's a copper wire. Something much more interesting is happening, a real chemical change. This whole process has a name, electrolysis. It sounds fancy, but if you break it down, electro for electricity and lysis means to split. So we're literally using electricity to split apart chemicals in the water. It's this incredibly powerful technique that's actually been around since 1800, discovered by a chemist named William Nicholson. And the best part is, you can actually see it happen. If you do this experiment, you might see little bubbles of gas fizzing up from the wires, or you might see shiny new metal starting to coat one of the wires. Even the color of the water itself can change. These are all signs that a chemical reaction is taking place. Now, this is where everything we've talked about clicks into place. This is way more than just a neat science experiment. That little effect we just mentioned, the one where metal starts to appear on a wire, that's the key to an incredibly important technology we use every single day. It's called electroplating, and it's exactly what it sounds like. We're using electricity to plate or coat an object with a thin layer of metal. I love this analogy. It's like painting with electricity, but instead of paint, you're using atoms of metal. And the way it works is actually pretty straightforward. You take the thing you want to coat, say a plain old iron spoon, and you dunk it in a special solution that has particles of another metal like silver floating around in it. You hook the spoon up to the negative side of a battery. When you turn on the power, the electricity pulls those silver particles out of the water and they stick right onto the spoon, forming this perfect, even coating.
So why do we do this? Oh man, for so many reasons. It stops things from rusting, it gives stuff that awesome shiny look, it makes surfaces tougher and harder to scratch. It's how we make gold-plated jewelry, by putting a thin layer of real gold on a much cheaper metal. It's ingenious.
And once you know what to look for, you see it everywhere. You know the super shiny chrome on your bike's handlebars or the faucets in your bathroom? Guess what? That's not solid chrome. No way, that'd be crazy expensive. It's actually a strong, cheaper metal that's been given a beautiful, durable chrome coating using electroplating.
Or about this one, food cans. Most of them are made of iron, but you don't want your food touching iron because it can react and go bad. So what do? They electroplate a super thin, safe layer of tin on the inside. It's a simple little trick that's absolutely vital for keeping our food safe.
And really, that's the whole story. From the shiny bumper on a car to the ring on your finger, this brilliant use of chemistry and electricity is just fundamental to the world we live in. It's this invisible force constantly working behind the scenes. So, think about it. We started with a simple warning your parents probably told you, don't mix electricity and water, and we ended up with a technology that protects our food, beautifies our homes, and makes our world more durable. It just goes to show you, when we understand the basic rules of science, we can do some pretty incredible things. Makes you wonder, doesn't it? What else is out there waiting to be discovered?